Multiplying polynomials part 2. So here's something that you learned in the last lesson. X plus 3 times x plus 3, a binomial. And we're going to use this FOIL method first, outside, inside, last. You can use the algebra tiles if you want, but you know what? You should try to wean yourself off of them and be able to do it this way. FOIL first. We fish that with that. The first term with the first term, you get x squared. Then the outside terms, that x with that 3. X times 3 is 3x, positive 3x that is. 3x times x to give us the inside gives us 3x. And then the last terms, this last term with that last term, 3 times 3 is 9. Positive 9. In the last step, you collect any like terms. The x squareds are done. The x's, there's 2 of them. 3 plus 3 is 6. And then you bring down the 9. X squared plus 6x plus 9. Now, what I'm going to lead up to in this video is, let's see if you can figure out a shortcut in doing certain, not every single, but certain binomial multiplications like this. Could you have done this in your head without doing this step here? Look at this. Look at that. Is there a shortcut that you can see? No? Okay. Let's move on. How about this? FOIL, first term, a times a squared. Outside, a times 5, positive 5a. Inside terms, 5a times a is positive 5a. Last terms, 5 times 5, 25. Collecting the like terms, hopefully you get their message now that it's always the middle ones that are the like terms. A squared plus 10a plus 25. Done. Again, do you see any patterns? Or anything that you see that could allow you to do this step here and jump right to this step there in your head without having to do that step? Okay. Now this, what is this? 5 plus 6n squared. That's an n. What is that the same thing as? Well, it's the same thing as 5 plus 6n times itself. 5 plus 6n. So that means that. And yeah, you know, above here, I could have written a plus 5 times a plus 5 like this. A plus 5 squared. That would have been the same thing. And just like up here, x plus 3 times x plus 3 is the same thing as x plus 3 times itself, or squared. So they mean the same thing. It means the same thing. It means the same thing. All right, so let's do this. 5 times 5, 25. 5 times 6n, 30n. 6n times 5n, 30n. 6n times 6n. 6 times 6, 36. N times n is n squared. And then these are our, oops, forgot the n there. Like terms, so you end up with 25 plus 60 n plus 36 n squared. Normally you write the one with the higher degree, the n squared, first. Doesn't really matter, it's not wrong, it's just better. 36 n squared plus 60 n plus 25. That's your answer. Now, looking here, could you have done that in one step down here without doing all this? Could you have done that, got that, sorry, from looking at that? It's the same thing in the questions above. Have you seen a pattern? Have you found a pattern? How about this one here? 2 times 5 plus a squared. Well, like I said, the 5 plus a squared is the same thing as, now it's just this that we're squaring. We're not squaring the 2 over here. It's just whatever's in brackets is squared. So it's 5 plus a times 5 plus a, and let's not forget the 2 in front. So you do this 2 different ways. I'm going to leave the 2 for later. Let's worry about that later. Let's first multiply these guys here. I know it's hurting your bedmass brain because you think, oh, left to right, but no, let's just do this first and we'll multiply it later. It makes no difference when you multiply anyways, the order that you do things in. 5 times 5 is 25. 5 times a is 5a. a times 5 is the exact same 5a. a times a is a squared. That leaves us with, we're going to collect these two, 25 plus 10a plus a squared. And then don't forget about that 2 out front. We're going to multiply it. Before we do that, could you have done, looking at this, could you have gotten to here without doing this? I'm asking with that trick again. Do you see the trick? Some of you probably are getting it, some of you aren't. Anyways, don't forget the times 2, everything. That 2 fishes everything inside. So you get 50 plus 2 times 10a, 20a, 2 times a squared, positive 2a squared. Yeah, we should put that out front, but let's not this time, just to be wild and crazy. All right, now what if you have this? X minus 4 squared. Well, that's the same thing as saying x minus 4 times itself. X minus 4. Let's do this. X times x is x squared. Now, there's negative signs here. X times negative 4 is negative 4x. And this now we're doing the inside terms. Negative 4 times x is negative 4x. And negative 4 times negative 4 is positive 16. So you end up getting x squared, and then collect these two like terms. Be careful of the signs. You're down 4, you're down 4 more, you're down 8x plus 16. Could you have seen something there that could allow you to get that without doing the middle stuff? Not sure. How about this? This is the same thing as 3x, whoops, sorry, 3x minus 2 times itself, 3x minus 2. And yeah, if there was a 3 there, then it would have been one of those, and another one over here. If there was a 10 here, then you'd have 10 of these. I hope you get the exponent deal. Anyways, that times that. 3 times 3 is 9, and don't forget the x times x, which is x squared. And then the outside terms, 3x times negative 2, don't forget about that, negative 6x, negative 2 times 3x is negative 6x again, negative 2 times negative 2 is positive 4, we end up getting negative x squared. Let's not forget to collect these suckers. You're down 6, you're down 6 more, you're down 12. Plus 4, again, could you have gotten that by just looking at that? How about this? Instead of 2 pluses and 2 minuses, now we have a plus and a minus. So let's FOIL this. X times x, x squared. X times negative 6, negative 6x. Now we're going to do positive. I guess I should have, for those of you who are following exactly what I do and get bothered by me doing something slightly different. First, outside, x times negative 6 gives you negative 6x. Now we do the inside terms. Positive 6 times x is positive 6x. Positive 6 times negative 6 is negative 36. These are our like terms. What happens to them? Plus 6, minus 6. You're up, down 6, then you're up 6 more. You're 0. We're left with just x squared minus 36. Again, do you see something here that would have let you do this in one step? Because again, this is the same way you could write, actually you can't. You could have written that, I'll stop talking. Just ignore what I just said. Anyways, here, what do you think? Can you do this in your head? Go for it. I'll give you 5 seconds. 1, 2, 3, 4, 5. Okay, let's see if your answer is the same as mine. Of course, you could have paused it to get more time, but whatever. A times a squared. A times negative 4, don't forget what the negative sign is, negative 4a. 4 times positive a is positive 4a. 4 times negative 4, negative 16. What do we do with the like terms? Plus 4 minus 4 becomes 0. It's a squared minus 16 is your final answer. Okay, so now I'm going to help you out. Probably thinking he's talking about these little hints and clues, but you're not really helping us out. What did you notice about these three types of questions? When you have two positive numbers multiplying each other, like we did in the first set, like there, like there, like there. What do you notice in those questions? Compare that to when you have two negative binomials multiplying each other, like there and there. And what about when you have a positive and a negative, a mix? What do you notice about them? Like here and here. What do you notice? Well, when you have this situation here, here's what you do. And again, if you don't have to do this trick, you can do it the old-fashioned way above. I'm just showing you a shortcut if you like it. When you see something like this, the same binomial multiplied by itself, that means it's squared, you just square everything inside. But there's one little trick. So what is 3a squared? It's 3a times 3a, which is 3 squared is 9, and a squared is, well, just a squared. Leave some space. What's 4 squared? 16. Now, that's all good. Here's where the tricky part is. Now what you're going to do is you take these two numbers, the 3 and the 4, and you're going to multiply them. 3 times 4, 12, and you're going to times them by 2 to make 24. And that's how much of the variable we have, 24a. So that is that. I wonder, did I do that question above here? 3 plus 4, 2 plus 4, 3 plus 4, 3 plus 4. Did I? No, I guess I didn't. But let's just do that same style question with this. Remember, this is the same thing as that. So let's use a rule. Let's take the first number, square it, x squared. There it is. Then take the second number, the 3, square it, get your 9. The middle term, this, we get by taking the numbers, which in this case are 3 and an imaginary 1. 3 times 1 is 3, times 2, 6x. For this one right here, a plus 5 squared, which we found the answer was this, doing the long way, the shortcut way, you would get a squared, there it is, 5 squared, there it is. You always leave some space in the middle, and then you multiply the numbers, 5 times imaginary 1, which is 5, times 2 gives us 10a. Same thing happened here. 5 plus 6n. 5 squared is, there's the 25. 6n squared is 6 times 6, 36. N squared. Take the two numbers. 5 times 6, 30. Times 2 is 60. So there is a trick, shortcut. Whenever you see a binomial, a square, a binomial times by itself with positive numbers, you could do this. That little trick there, to square the first and last terms and then multiply the numbers, the coefficients, the constant, I guess, and times it by 2 to get the middle term. How's it different for the subtracting? Well, it's pretty much the same. That's the answer for that. You're going to do the same thing. 3a times 3a, or 3a squared is 9a squared. 3 squared is 9. A squared is that. Now, negative 4 squared means negative 4 times negative 4. Remember from your exponent rules, negative times negative is positive. You're actually going to get positive 16. Now we're going to multiply these two numbers, but this time we have 3 times, that minus sign belongs to the 4, 3 times negative 4 is negative 12. Negative 12 is negative 12. Now we're going to take that and times it by 2, we get negative 24a. Which again, I'll show you, just to prove that it works, with the negative 1 here. There we are. The minus sign, that becomes 9x squared. Negative 2 times negative 2 is positive 4. You take the 3 times the negative 2, which is negative 6. Negative 6 times 2 is negative 12. Don't forget the x goes with it. The variable goes with it in the middle term. All right, what about the last one? This, when you have a differing signs. Well, when you have differing signs, do you not notice in the last two questions, when you have one positive and one negative, you get this thing happening in the middle. The two terms cancel each other out, just like they did here as well. The two terms canceled each other out. You've got a positive term multiplied by a negative term, and they cancel each other out. So you don't have to worry about the middle term, and you just square it as normal. Like for this one, x plus 6, x minus 6, you just go, again, which is x squared, and then 6 times negative 6, negative 36. So the key trick is identifying when you see the certain binomial, knowing which type it is, and then knowing what to do. If it's too much responsibility for you, you don't think you can handle this, it's too difficult, you can always do it the old-fashioned long way. So this one here again, when we see that we've got a binomial times almost the same binomial, they just have different signs, we know that the single variables, the a's in this case, are going to cancel each other out, and you're just left with the a squareds and the 4 times negative 4, negative 16. So for this one here, how would you do it? You would just go 3a times 3a, which we have found out before is 9a squared. And we don't care about the middle terms. This plus and this minus, they're gonna, when we do all the multiplying, they're gonna cancel each other out. The a's will be gone. And then you just do the last term, 4 times negative 4, negative 16. And that's your answer. That one's for that one's for that. And so pick your method. Here's 3 skill testing questions. Do whichever ones, do whatever method you like, the long way or the shortcut way, but do have them done. Thank you. Bye-bye.